Okay, make sure we're in focus. Let's talk about a fundamental triangle. Now, very simple idea. Fundamental triangle consists of, for 2 points, fundamental triangle for 2 points. You always have to have 2 points to do a fundamental triangle. You draw a line segment from one point to the other, and that's going to be the hypotenuse of your fundamental triangle. So there's your hypotenuse. You draw one leg parallel to the x-axis. Now that leg could start at this point or at this point. I'm going to start at this point because if I start at this point I got to go through the word hypotenuse, but there's no reason I couldn't have started at this point and put that word somewhere else. Okay? But I'm going to start at this point. It doesn't matter which point you use, you draw a horizontal line. And then through the other point you draw a vertical line that meets up with that horizontal line. So that this line is parallel to the x-axis, this line is parallel to the y-axis. Okay? Then you determine a positive direction. You draw a little arrow that goes from one point to the other. Okay? Now one way to get from this point to this point is to just go straight along the hypotenuse. Maybe you want the scenic route. Well, you still want to go from this point to this point, so you follow this path indicated by these arrows. Both cases, you're going from one point to the other. If I move from here to here, how far do I go? Well, I'm going from where x is -3, so x would be -3 here, up to where x is 7 here. I'm not going to label that, but sorry, x is 12 here. That's I'll get it, yeah, x is 5 here, okay? 7 caught the corner of my peripheral vision, I guess, something. Anyhow, x is 5 here, so not going to label that, but we go from -3 to 5. Now how do we get from -3 to 5? Well, we got to go 3 units to get the origin, and then 5 more units to get here. So this side is a run of 8. Okay, now we're going to call this side the run, we're going to call this side the rise, and if you're in this pre-calculus course you know what I mean by rise and run, and you know that slope is rise divided by run. Okay, well, that's the run. It's from here to here. The rise is from here to here. The rise is then from supposed to be -3, -7. Anyhow, from -7 up to 12. Well, if you go from -7 up to 12, you got to go 7 units in this direction, and then 12 more units in this direction. So your rise is 12 and 7 is 19. Now this graph isn't to scale. Scale's bad. If this is 7, then yeah, it's not that far off. Okay, anyhow, there we have it. We have a rise of 19, a run of 8. So now we can say that the slope is rise divided by run. I despise the formula y2 minus y1 divided by x2 minus x1. Now, I'm overstating it. I don't really despise it. It's a good way to keep your coordinates straight and everything, but it doesn't have any geometrical or intuitive meaning. And people use it all the time without intuitive meaning and make mistakes in doing that. Besides, they don't get the intuitive idea of a slope. It's just something you plug numbers into. No, it's rise divided by run. there's your slope. Now, on a fundamental triangle, I use the convention that the slope is going to be written next to the hypotenuse. There's my slope, 19/8, with a rectangular box around it to indicate that this is not a distance, it's a slope. Okay. Well, another thing about the fundamental triangle is that the hypotenuse has a length. Okay, so the length of the hypotenuse equals the square root of the rise squared plus the run squared. In other words, the Pythagorean theorem says that the square of this distance is the sum of the squares of this distance and this distance. And I assume everybody knows what the Pythagorean theorem says and has used it, again, too much in the context of a formula rather than an idea. We want to connect the formula with a picture. Okay, well then 8 squared is 64, 19 squared is 361, that gives you 425, I think. Put a question mark there, check my arithmetic, I make mistakes. Okay, now, fundamental triangle related to slope, well there it is. If we have a graph and we want to calculate an average rate of change based on the graph, and let's say we want to calculate an average rate of change on the interval from, let's say x is equal to 3 here and 8 here. Okay, again, not very accurate. 7 might have been a better number, but we're going to use 8. Okay, so with the average rate of change in the interval 3, 8. That's going to be depicted as follows. We come down to the point here where x equals 3. Right there's the point where x equals 3. Here's the point on the graph where x equals 8. And the average rate of change is going to be the slope of this line segment, which is the slope of this fundamental triangle. So that's a fundamental triangle for the points 3, f of 3, and 8, f of 8. So you have a run. First of all, let's choose positive directions. You have a run of 5 and a rise. Well, I don't have a scale on this thing on the y-axis, but let's go ahead and say, okay, well, we don't know what these coordinates are, but if there is a scale on the y-axis, we can read it, and we can see that maybe this point is where y equals -1, and up here maybe y equals 9. Okay, then we can see that the rise is 10. So the slope is 10 over 5. And that's 2. So we put 2 in a box here. Well, that's the idea of a fundamental triangle. It helps you visualize the slope. Gives you a picture of what it means to calculate the rate of change, the average rate of change between this point and this point. Okay, this has got to be the change in y, this is the change in x, and you divide those two. It's the same as doing rise divided by run. It's the slope, it's also the average rate of change. And this picture, I think, is important. The picture of this triangle and the idea of this triangle is important in pre-calculus. It's especially important in calculus when you're trying to get the idea of a derivative. And I require it in my course. I require you to be able to use and represent things by fundamental triangles in your written work. And of course I work with you on that because your book is going to just give you a formula. Now the formula is great. You would also maybe want to do the formula. Okay, so after you do the fundamental triangle, you could say, okay, well, let's see. My calculation here would be, let's do it in a different color to show it doesn't really matter, would be okay, for these points, that would be 12 minus negative 3, negative 7, divided by 5 minus negative 3, and you do the arithmetic, and that ends up with 19 over 8. Okay, so it works. And you could do the same thing here. Again, when you're especially learning to interpret graphs and so forth, which is important throughout pre-calculus and calculus and well beyond, you want a picture. And this picture tells you what's going on. The formula just gives you an answer. Now, once you understand the picture, you can see the picture in the formula. That's when you really understand it.